Hello students, welcome to my YouTube channel Concept Clear, where I am making different types of video to clarify, to clear your doubt. Uh, Today I am making a new video of a decoder circuits. I hope these videos will help you to clear your doubt, to enhance your knowledge and skills, and will give some benefit in your life. Let us go to the topic what I am going to discuss. So now I'm going to discuss about a decoder circuits. Then I'll tell how to write the code of a 3 to 8 decoder circuits in Verilog style by the help of Xilinx Vivado tool. Then that Verilog code can be verified by the help of the Testbench, which also will be written in that Verilog tool in Xilinx Vivado. So before going to the Vivado tools, let us understand what is decoder circuits. Generally, a decoder circuits is what? It is a circuits which will have n input and 2 to the power n output. So this is an block diagram of a decoder circuits. So here we will see there will be n input will be there and 2 to the power n output will be there. That means if you are considering for 3 to 8 decoder, then it will be 3 inputs will be there and 8 outputs will be there. So I'm taking here 3 to 8 decoder. So it will have 3 inputs. Let us consider the input is A, B, C, and the output will be can be taken as 7 output. Okay. So I'll take from Y0, Y1, and Y7. Okay. So if I am taking 3 inputs, then we will get 2 to the power 3, that is 8 outputs will be there. Y0 to Y7, that is 8 output. Now what is the logic in 3 to 8 decoder? The logic is like that. Since it has 3 inputs, there will be 2 to the power 3, that is 8 different combination will be there. With respect to one combination, one of the output will be active, that means it will be 1, remaining outputs will be become 0. For example, if I am taking the input 0 0 0, that means A is 0, B is 0, C is 0, then in the output Y0 will be 1, remaining like Y2, Y3, Y4 up to Y7 all will be 0. Okay. Similarly, if I am taking 1 1 1, then Y7 will become 1, remaining will become 0. That is the logic in 3 to 8 decoder circuits. Let us go to the circuit and truth table. This is the truth table of 3 to 8 decoder. A, B, C are taken as 3 inputs. Y7, Y6, Y5, Y4, Y3, Y2, Y1 and Y0 as the outputs. Now you can verify here. If I am taking 0 0 0, then only Y0 is 1, remaining is 0. Similarly, if you am taking 0 0 1, Y1 is 1, remaining is 0. Similarly, if you are taking, for example, 1 1 0 is the input combination, then Y6 is 1, remaining will be 0. For understanding, you can find the decimal value of this 110, its decimal value is 6, so Y6 is 1, remaining will be 0. Similarly, 111, the decimal value is 7, Y7 is 1, remaining is 0. That is the logic. Then from this truth table, by the help of K-map, we can solve it and we can get the expression of output in terms of input. So now simply I can tell here what is the Y0 expression? Y0 is equal to A bar into B bar into C bar. So I can write here like Y0 is equal to A bar into B bar into C bar, because whenever A is 0 it will be 1, whenever B is 0 it will be 1, whenever C is 0 it is 1, so 1 into 1 into 1, that is 1, so Y0 is this one. So from this we can easily find out what is the output expression in terms of input. After finding out that expression, we can make a circuit diagram. As you can see here, this is the circuit diagram. A, B, C are the inputs is taken, then there are 3 NOT gate is used and followed by 8 AND gate is used. These are the AND gates. So for Y0, Y1, Y2, for each output we are using one AND gate. That AND gate will have 3 input and 1 output. Okay. So from the expression and from this logic diagram, circuit diagram, we have to write the code in Verilog and we have to verify it. So whenever we are going to write the code for 3:8 decoder in structural or gate level modeling, then we have to take the help of the circuit diagram. So in the circuit diagram, what are the primary input, what are the primary output, and the intermediate input and output we have to find out. So here A, B, C is known as primary input, Y0 to Y7 is known as primary output. Okay, so in between any input output is coming, that is known as intermediate input and output. Now here you can see this NOT gate is coming. Now this NOT gate will give some output. Let us consider this is W3, this is W2, this is W1. When the A signal is passed through the NOT gate, whatever output we are getting, that is W1. Whenever B is passing through this NOT gate, we are getting the output W2. Whenever C is passing through the NOT gate, we are getting the output W3. This W1, W2, W3 is 3 input which is in between primary input and primary output. This is known as intermediate input or output. So whenever we have to write the code, we have to write this W1, W2, W3 as wire data type, which will pass the signal from one terminal to another terminal. Understood? Now with respect to this logic diagram, this circuit diagram, let us go and write the Verilog code in Vivado software. This is the Vivado software where we have to write our code in Verilog. Now I will go to add source, add or create design source. Next I will create a file. Let us write the file name as decoder underscore 3 underscore, or we can write decoder, okay, underscore s. So remember that whenever you are writing the file name, it should start with a letter, it should not start with number, because why? Because file name will we are taking as a module name. The module name syntax is it should always start with a letter, it should not start with number or special character. Okay, so we'll go to finish. Here you can see that this is the module name. Since we are taking the same file name as a module name, so we have to follow the module name syntax. Then I have to give the input here 3 to 8 decoder, so 3 inputs will be there. Let us write A, B, C as 3 inputs. Then output, since output can be taken as a vector, so I'll take a vector. Why? You can take as scalar, but scalar means it will take much time to write that. Okay, so I'll take a output Y. This can be output, it can be bus, the size can be 7 to 0. So this is MSB 7, LSB 0. Okay, now it is created here. Now we have to write the code for that decoder. It's very simple, only write in the structural or gate level modeling, but the difficulties will come whenever the complex circuit will be there. When the circuit will be more complex, you cannot write in gate level or structural modeling. So here what I have to write, I have to first declare the wire, the intermediate output we have to declare W1, W2, W3. These are the 3 intermediate output. Then I have to write the different gate. So what are the gates are here? I will show here the circuits. So you can see that 3 NOT gate is there, 8 AND gate is there. So for the if I am considering this is first NOT gate, for this one output is W1, input is A. This one output is W2, input is B. This one output is W3, input is C. So first let us write for the NOT gate. So NOT, then I will give one name G1. Why we are giving this G1? To only differentiate the NOT gate, because 3 NOT gate is there. Which NOT gate you are writing? So we are giving some name. This is optional. If you not write also, it will come. G1 output is W1, input is A. Then another NOT gate, output is W2, input is B. Another NOT gate, output is W3, input is C. So the intermediate output W1, W2, W3 is over. Next we have to write for the remaining AND gate. So first let us see how the AND gates are there. So for example y0, when y0 is output, what is the inputs we have taken? This is connected to not get output, this is connected not get output, this is connected not get, means w1, w2, w3. Similarly this one w3, w2, and this is a. So like that we can see the connection here, and we have to write the code. If it is passing through the NOT gate, that value will be w1 or w2 or w3. If it is directly connected, then that can be a or b or c. Okay, so I'll write the AND gate here. So in the AND gate also we have to give some name for differentiating the AND gate, G4. Then I will write the output y0. Many students doing mistakes here. So whenever you have declared y as a vector, then you have to write the 0 in a square bracket. If without any square bracket, open close bracket, or simply you are writing 0, then you will not get the output. It will show runtime error. Then input is w1, w2, w3. Okay. Similarly, next another AND gate will be there. For that one, we give G5. Output is y1, comma w1, w2, c. And also every time the statement is completed, then you have to close with the semicolon. Like that we have to write for 7 lines. Now I have written for all output like y0, y1 up to y7. What is the combination? Like y7 it is abc. So by seeing that gate here, what is the for example y7, what is the terminals? A, B, C are connected. So by seeing the logic circuits, you have to write the code here. Okay, then what we have to do? We have to save it. Once I saved, if any syntax error is there, then it has to show here. If no syntax error, then you have to go for Testbench, or you have to do the simulation with force constant. If the syntax error is there, then you have to first verify the syntax error, then you have to go for the simulation. Okay, so now since it is not showing any syntax error, let us go and write the Testbench for this design source. We'll go to add source, then add or create simulation source. Next, so create a file, give the same name like decoder underscore tb testbench, and this is a test bench. This is not a design source module, so we'll finish without any input and output port. Now this design source is showing here. So we have to write the input code for this one. First we have to declare the number of input variable as a register and the output variable as where. So I have 3 input variable a underscore a b c. So I'll take 3 input variable here, register data type a underscore t, b underscore t, and c underscore t. And I will take the output where 7:0 y. Okay, so after declaring the input and output, next we have to instantiate our module. That is first module name. I have written the module name as decoder underscore 3 to 8 structural, then some name dot, then we have to call the input and output variables like dot a underscore t, dot b underscore t, dot c underscore t. Okay, 3 are there. Then output dot y underscore t. So here I have to declare this one as y underscore t. Okay, so here instantiation is over. By saving here also you can see that in the simulation source it is showing that this is coming under decoder tb is decoder 3 underscore 8 underscore s. Region source is coming here. It is showing errors because we have not initialized, or some other errors we have to see here. For example, this is one error. I'll save here, so there is no errors. Now you have to write the different combination of input with the initial block. Okay, initial begin, then a underscore t equals to 0, b underscore t equals to 0, c underscore t equals to 0. Okay, then after some time delay we have to give other combination. Since 3 inputs are there, we know that there will be 2 to the power 3, that is 8 different combination will be there. So let us write for all combination with some delay. So I have written all combination of input terminals or input variables from 0000 to 111. After that we have to finish it, so we have to give some 10 nanosecond delay, then the system function $finish. With this our test bench is over. No, not yet, because we have begin here. Whenever there will be begin, you have to end it, so I have to write end. Then I will save here and I will see any errors are there or not. So it is not showing any syntax error here. That means my test bench code is correct. Now I can go for the simulation. If any other errors should be there, then it will show in the simulation, then we have to rectify it. Okay, now simulation waveform came. We can maximize it, then we have to zoom and fit, and we can see this one. So now you can see that this for different combination what is the output. Already from truth table we know. So if my input is 000, then output should be first 7 will be 0, next will be 1. Similarly, if the input is 001, then first 6 will be 0, then 10. Next, similarly, my input is if 100, then first 3 will be 0, then 1, then 40. Similarly, if you are going for the last combination 111, you will get 1, then followed by all 0. This is with respect to the truth table. So we are getting the truth table here. Whatever truth table is there, with respect to that truth table, you are getting the waveform there. Okay. So I hope you understand decoder circuits in better way, and I thank you all for watching this video. If any doubt will be there, please do comment in the comment section, and please if you like this video, like it and subscribe the channel. Thank you.